Hello. This is just a continuation of our topic in my first video, solving quadratic equations by extracting square roots. Okay, before that, let us look at the numbers inside the radical symbols. We have 1, 4, 9, 16, 25, and so on and so forth. So they are all perfect square numbers. Now, if you're going to get the square root of 1, okay, if you're going to get the square root of 1 that is equal to 1, because 1 squared is equal to 1, or 1 times 1 is equal to 1. Square root of 4 is equal to 2, because 2 squared is equal to 4, or we have, or 2 times 2 is equal to 4. The next, square root of 9 is equal to 3, because 3 squared is equal to 9, or 3 times 3, that is equal to 9. Then square root of 16 is equal to 4, because 4 squared is 16. Square root of 25 is equal to 5, because 5 squared is equal to 25. Square root of 36, that is equal to 6, because 6 squared is equal to 36. Square root of 49 is equal to 7, because 7 squared is equal to 49, or 7 times 7. Then square root of 64 equals to 8, because 8 squared is equal to 64. Square root of 81 is equal to 9, because 9 squared is equal to 81. And then square root of 100 is 10, because 10 squared is equal to 100. Square root of 121 is equal to 11, because 11 squared is equal to 121, or 11 times 11, that is 121. Then square root of 144 is equal to 12, because 12 squared is equal to 144, or 12 times 12 is equal to 144. Okay, let us have an example number 1. We have 4x squared minus 121 equals 0. So first step is you have to add 121 on both sides of the equation. So we have 4x squared minus 121 plus 121 equals to 0 plus 121. Now cancel negative 121 and then positive 121. So we have 4x squared is equal to positive 121. From the quadratic equation of the form x squared equals to k here is 121. And then, from the properties that we have learned, if k is greater than 0, then there are two real solutions. Now, get the square root of both sides. So we have square root of 4, that is 2. Then square root of x squared, if we're going to write that into exponential form, that is x raised to the exponent 2 over the index 2 here. So that is x only. 2 divided by 2, that is 1. So that is x only. So going back here, we have square root of x squared, that is x, then equals to square root of 121, that is positive or negative 11. Notice that we have numerical coefficient. We have 2 as the numerical coefficient of the variable x. So divide both sides by 2. We have positive or negative 11 over 2. Cancel 2. Then x is equal to positive or negative 11 over 2. So we have two real solutions, which are positive 11 over 2 and the negative 11 over 2. So we have two values of x. So we have x of 1 is positive 11 over 2. And then x of 2 is negative 11 over 2. So to check, if x is equal to positive 11 over 2, So using the original equation, so we have 4x squared minus 121 equals to 0. We have 4 times 11 over 2 squared minus 121 equals to 0. So you have to copy 4 times 11 squared, that is 121, or 11 times 11. Then over 2 squared, that is 4, or 4 times 4 minus 121 equals to 0. Now the denominator of 4 is 1. So you can now cancel 4 as the numerator and then 4 the denominator of the second term. So that is 1. So we have 1 times 121 is 121 over 4 times 1 times 1, that is 1. So minus 121 equals to 0. So 121 minus 121, that is 0, equals to 0. If x is equal to negative 11 over 2, now using again the original equation, we have 4x squared minus 121 equals to 0. So we have 4 times negative 11 over 2 squared minus 121 equals to 0. So copy 4. Then times negative 11 squared, that is 121, over 2 squared, that is 4. Then minus 121 equals to 0. Denominator of this is 1, so we can cancel now 4 and then 4 here. So we have 121 minus 121 equals to 0. So 0 equals to 0. Check. So both values of x satisfy the given equations. So our answer is that the equation 4x squared minus 121 equals to 0 has two solutions. That is, x is equal to positive 11 over 2 and x is equal to negative 11 over 2. Okay, number 2 example. If we have x squared minus 11 equals to 0. Now, add 11 on both sides of the equation. So we have x squared minus 11 plus 11 equals to 0 plus 11. Then cancel negative 11 and then 11. Then we have x squared is equal to 11. The next is you have to get the square root of both sides. So we have square root of x squared is x. Then square root of 11, so that is positive or negative square root of 11, since that 11 is not a perfect square number. Then our first root is positive square root of 11, and then second root is negative square root of 11. So let us check. If x is equal to positive square root of 11, using the original equation, we have x squared minus 11 equals to 0. So you substitute, we have square root of 11 squared minus 11 equals to 0. Then we have here square root of 11 squared, that is 11y. So let us put aside here. Now if we have square root of 11 squared, if we are going to write this into exponential form, that is 11 raised to the exponent, so that will be the numerator of the exponent, over 2 from the index to here. So that's why the answer is 11 raised to 1, or 11 only. Then minus 11 equals to 0. So 11 minus 11, that is 0, equals to 0. Check. Then another one, if for the second value of x, if x is negative square root of 11, so we have x squared minus 11 equals to 0. So again, substitute negative square root of 11. Negative square root of 11 squared minus 11 equals to 0. Then the numerical coefficient here is -1. So negative 1 is squared, that is positive 1. Then square root of 11 is squared, that is 11 only. Then minus 11 equals to 0. Then 11 minus 11, we have 0 equals to 0. Check. Since that both values of x satisfy the given equation, therefore, the solutions are the solutions of the equation, the solutions are positive and the negative square root of 11. Okay, number 3. We have x squared minus 18 equals to 0. Then again, add 18 on both sides of the equation. So we have x squared minus 18 plus 18 equals to 0 plus 18. Then cancel negative 18 and then 18. So we have x squared is equal to 18. Get the square root of both sides. So we have square root of x squared is x equals to 18 is not a perfect square number, but then 18 has factors wherein one of its factors is a perfect square number, which is 9 and 2. Now 9 is a perfect square number. If we're going to get the square root of that, that is equal to 3. Therefore, we have here positive or negative square root of 9 times 2. Then we have here x is equal to positive or negative square root of 9, that is 3. Then you just copy square root of 2. So here our first root or our first solution is positive 3 square root of 2. And then our second solution is negative 3 square root of 2. So to check, if x is equal to positive 3 square root of 2, using the original equation, x squared minus 18 equals to 0. Substitute, we have 3 square root of 2 squared minus 18 equals to 0. Then 3 squared, that is 9. Then square root of 2 squared, so that is 2. Then minus 18 equals to 0. Then 9 times 2 is 18. Minus 18 equals to 0. So 18 minus 18, that is 0 equals to 0. Check. Then if x is equal to negative 3 square root of 2, then we have x squared minus 18 equals to 0. Then negative 3 square root of 2, that is the value of x, right? Then minus 18 equals to 0. So negative 3 squared, that is 9. Square root of 2 squared, that is 2. Minus 18 equals to 0. Then 9 times 2, that is 18. Minus 18 equals to 0. So 18 minus 18, that is 0 equals to 0. Check. Now, since that both values of x satisfy the given equation, then the solutions are x equals to positive 3 square root of 2 and or x is equal to negative 3 square root of 2. So that's it for today. I hope you learned a lot today. For more math tutorial videos, please like, subscribe, and then click the notification button. For more examples and then exercises of solving quadratic equations by extracting square roots, you can move to my next video, solving quadratic equations by extracting square roots, part 3. Thank you very much and have a good day.